There are three theorems that allow us to determine whether two triangles are similar. We've already looked at the first one. It's the angle-angle similarity theorem, or AA theorem. Now we're going to look at the side-angle-side similarity theorem, which we sometimes shorten to just SAS. And in that theorem, we're told that in two triangles, if a pair of corresponding angles is congruent, and the word "and" there is very important because there are two conditions here that must be met. So if a pair of corresponding angles is congruent and the sides including the angle are proportional, then the angles are similar. Now let's understand what this means when we say including the angle. If you'll notice, the angles that are highlighted in yellow are formed by two sides. Those two sides include the angle. That's what we mean when we say the sides including the angle. It's the two sides that form the angle. So let's look and see how this theorem works. So in example 3, we're asked to answer the question, can the two triangles be proven similar by using the SAS similarity theorem? And if so, let's write a similarity statement. Well, to use this theorem, we must first find a pair of congruent corresponding angles. And what I notice very quickly is that we have two congruent corresponding angles. Angle N and angle R. They're both 120 degrees. So we've met that first condition. But now we need the sides that include the angles to be proportional. Well, we'll need to find some sides that correspond that have numerical value. And I notice that MN has a value of 4, and corresponding to MN is PR, which has a value of 6. And so we write a ratio of 4/6. Then we can write a ratio between side LN, which has a value of 6, and side QR, which has a value of 9. So two ratios of corresponding sides. Now we're going to cross multiply. When we cross multiply, we get 4 times 9, that's equal to 36, and 6 times 6 is equal to 36. And we've already learned that when you cross multiply two ratios and the products are equal, then the two ratios form a proportion. So these two pairs of sides are proportional. So we've met both conditions for the SAS similarity theorem, and so that's enough information to claim or decide or conclude that the two triangles are similar. Now we're going to write a similarity statement. Well, the first one I will write as triangle MNL. Now remember, we must write the name of the other triangle using corresponding letters in the same order. So triangle MNL is similar to triangle PRQ. The third theorem is called the side-side-side theorem. And it says that if the pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. Well, that means if I write ratios for the corresponding sides, all of those ratios will be equal. So let's look and see how that works. What we need then, for example 4, is to show that all three corresponding ratios are equal. So the first ratio we can write is between side ST and side XW, are 3 to 9, which simplifies to 1 over 3. We can also write a ratio for the corresponding sides of TU and WV, are 5 over 15, which also simplifies to 1/3. And the third ratio is between side SU and side XV, are 4 over 12, and that ratio also simplifies to 1/3. So all three ratios between corresponding pairs are congruent. So yes, these triangles are similar. And we can write the similarity statement. SUT, triangle SUT, is similar to triangle XVW. Now let's solve some problems regarding these similarity theorems. We're asked to determine whether or not the two triangles in each example are similar, and if so, state how they are similar. In other words, which theorem allows us to say that they are similar, and then write a similarity statement. So in example 5, notice we have two triangles. One triangle, triangle XWV, is embedded within a larger triangle, triangle XZY. And we notice, first off, that two angles are congruent. Corresponding angles are congruent. Angle XWV is 80 degrees, and angle XZY is also 80 degrees. So that's one pair of angles that is congruent. But notice there is also an angle there at X that is an angle in both triangles. So we can use what is called the reflexive property, that something is equal to itself. If we were to separate those two triangles, the angle where X is would be in the large triangle, and the angle where X is would also be in the small triangle, and they're congruent to one another. So now we've shown that corresponding angles in both triangles are congruent. That's two pair, so that's enough to show that the two triangles are similar. How? By the AA, or angle-angle similarity theorem. Now we write the similarity statement. Angle XWV is similar to angle or triangle XZY. Then in example 6, we have also two triangles, a smaller one embedded in a larger one, and they share one angle there at L. So there's an angle that is congruent to itself, even though the angle is a part of both triangles. So that's the only angle that we know anything about, so it looks like the similarity theorem that we're going to use is the SAS, because we are given information about the sides of these triangles. But notice, we can write some ratios with the sides. So the segment LK has a length of 6, and it corresponds to the side of the larger triangle LJ, which has a length of 6 plus 3 or 9. Then we can write a ratio for using the segment or side LM, which has a value of 10, and the corresponding side in the large triangle LN has a length of 10 plus 5 or 15. Now what's interesting is that by cross multiplication, 9 times 15 equals 90, and 9 times 10 equals 90. So those two cross products are equal, making the two ratios equal, and thus a proportion. And now we have shown that one pair of angles and the side are congruent, and the sides that include those angles are proportional. So by the theorem SAS, we know that these two triangles are similar using the SAS theorem, and we can write the similarity statement as LKM is similar to LJN. Then we have finally example 7. And in this example, we see no information given about any of the angles, but there is information given about the sides. So that tells me I'll probably use the SSS similarity statement. Well, what can we determine? Well, since there's no angles to compare, we can compare the sides. So notice, angle or side ED has a length of 3, and the corresponding side on the larger triangle HF has a length of 6, so we can write a ratio of 3 to 6. Then the side DG on the small triangle corresponds to side HE on the large triangle, so we can write a ratio of 5 over 10. And finally, the side EG of the small triangle corresponds to the side EF of the large triangle, and we can write a ratio of 6 over 12. And all of those equal 1/2. So we have shown that the three pairs of sides, corresponding sides, are proportional. Therefore, using the SSS theorem, we've determined that the two triangles are similar, and our similarity statement could be DEG is similar to triangle HFE.